Alrighty, let's see. We're going to do some factoring trinomials. And this is by a process called decomposition, which really means to decompose or to break down. So first thing we did is we were expanding. So that's like multiplying. So multiplying, we're expanding out or multiplying out polynomials using, oh yeah, FOIL. First, outsides, insides, last. So there's like 4 steps here. Now, we did it with algebra tiles. So you had like an x length and then plus 1, plus 2, plus 3, and then an x length, and then 1, 2, maybe I'll put the 3 here, and I'll put the 1, 2, 3, 4, 5. So this was a length of x, and then plus 5, right? 1, 2, 3, 4, 5. And this was an x plus 3, x plus 3. X plus 3 times. So we're doing area. Now, if I just extend these down, right, this is where we got all these little ones. So we had a whole bunch of x's, x, 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 and a big x squared. And then there was 1, 2, 3, 4. This is going to be 5 by, there's going to be 15 of them here. So it becomes 1 big x squared plus 1, 2, 3x plus 8x's. Plus 15. And we usually do them in order. We do the biggest one first, and then the longer ones, and then the tiny little ones in the corners. Do those last. That's a trinomial. Okay, so if you do it with algebra tiles, we also did it by FOIL. What? You remember? This is like saying x times x, which is x squared, x times 5, which is 5x, and then 3 times x, which is 3x, and then 3 times 5, 15. You see, you get the exact same things. 5x's, 3x's, there they are. X squared, there's the big one. And then the 15. It's just, this is a way more compact, and this is doing it algebraically. Now, if I do it in order, I usually find the middle two will usually come together. X squared plus 8x's plus 15. So the opposite of this is called factoring. So that's multiplying or expanding out. But the opposite is factoring. So factoring kind of is like dividing. What do two numbers divide into? So let's try this using algebra tiles. First off, x squared, 1 big x squared, right? I know it's a big x squared there. And then there's 10 x's. Well, okay, so there's a bunch of, and then there's 16. The 16 is the little number in the corner here, right? Because we did these in order. If we put the x's here and here, because that's the length, then all the little ones, the ones digits, they can go in the end. So let's see if we can try this thing. Hang on, let me actually try one. Do I still have them? Hey, I do. There's my x squared. Now it said what? 10 x's? Whoa. So what, should I do 5 by 5? I mean, I could try that, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Well, that's going to give me 25 here in the corner, right? That's not the question. The question, it didn't say 25. It was 16. Okay, so let's take one of these off. Put it over here. Instead of 5 by 5, let's make it 6 by 4. That's 24. It's not what I want. Let's try it again. What if I make this 7 by 3? Okay, well, that's now like 21. Oh, no. Here we go. Look. 1, 2, 3, 4, 5, 6, 7, 8 by 2. This is giving me 16 ones. That's what I want. So if I was to factor it, okay, I'm not going to physically do every one of those like that. But I know that if I do 8 of them here, 1, 2, 3, 4, 5, 6, 7, 8. So this is x plus 8. And there's 2 left. 1, 2. So this is x plus 2. 2 times 8 is 16. That's what I have down here in the corner. I've got 16 little ones. So really, the number on the end is a bit of a clue. It'll tell you how you can break up your x's. These are all x's. X, 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 x. Okay, so factoring it means I want to know the length and the width, the dimensions. So it's x plus 2 times x plus 8. So that's x plus 2 bracket x plus 8. I could have written it the other way around too. I could have said x plus 8, x plus 2. Who cares about the order? Length and width, width and length. Same thing. If I wanted to multiply this out by FOIL, I would get back to this trinomial. Okay, let's try this one. Hang on, 2x squareds. So there's a big x squared, and an x squared. So I know this is x, and this is just x here. Okay, so there's 7. So do I do 1 and 1, 2, 3, 4, 5, 6. No, 1. If I do 6 of them down here, I'm going to get 3. That's not what I want. Right? So I know these got to be doubled up. There's got to be X and X. What if I put 2 here? 2 and then there'd be 5. That's not possible. What if I put 3 here? So 3 here, and then 3, 4, 5, 6, 7. Hang on, would this work? X, X. So this is going to be 1, 2. Yeah, hang on, this works. This gives me the little corner down here, which is 3 by 2. So that's 6, and that's this number here. So this is a distance of x, x. So this is 2x, 1, 2, 3, plus 3. So 2x plus 3, that's my length along the top, and this is x, 1, 2. X plus 2. So I'm just building these things to make a rectangle, a length times width. Now I'm guessing. So basically there's a limited number of guesses, but I know this is 6 in the corner. It's got to be 6 by 1 or 2 by 3. It's one of those two. Okay, so we can't do these all the time with algebra tiles. Let's do them algebraically. So now we're going to have to use the distributive principle, or in other words, remember, we called this FOIL, first, outsides, insides, last, blah, 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 blah. So if I was to multiply them out, think about it. X times x, I know that's x squared. X times 7, 7x. Then 2 times x, 2x. And then 2 times 7, okay, 14. Okay, these middle two usually go together. There we go. X squared plus 9x plus 14. Okay, so recognize something. Take a look at the middle numbers, right? 7 and 2. They add up to 9. So in other words, the sum is 9. But 7 and 2, if I multiply them, I get 14. So the product is 14. So in other words, what are they times to? They multiply to 14, because I can see they multiply there in the end. But they add up in the middle, because they usually combine. And the x times x, I usually put that one first. Hang on, let's try this again. 3x times x, 3x squared. 3x times 5 plus 15x, 4 times x, plus 4x, 4 times 5, plus 20. Okay, so see these middle two numbers? They make 19x. So take a look at these two middle two numbers, 15 and 4. They have a sum of 19. And they have a product of 60. So if I multiply the two of them, I get 60. That's not 20. No, but look, it's 3 times 20. Oh yeah, in the same way, this was really 1 times 14. So they multiply to the outside, but they add up to the middle. So that's an important thing to recognize. So notice the pattern. Here's what it is. For that last one, the middle two numbers have a sum of 19. And they had a product of 60. Now that 60 wasn't the number on the end, but it's 3 and 20. So that was 3 times 20. That's where I got the 60 from. So really what we're doing is we're really just doing FOIL in reverse. So instead of starting here and going this way, if we start here, I want to be able to go backwards, right? What we're going to do is we're going to decompose the middle term, and then we're going to factor by grouping 2 and 2. Oh yeah, and then factor by grouping. I kind of remember that. Hang on, we'll see it. 2 and 2, the first 2 and the second 2. Okay, let's give it a shot. So let's try and do one of these algebraically now. So it says factor this trinomial. 2x squared, 9x. I got to break this down into two different numbers. What I want to do is I'm looking for two numbers that have a sum of 9. However, 2 times 4, they have a product of 8. So here's the thing. Don't start with the sum, because there's an infinite number of numbers that add up to 9. However, product, if you know they multiply to 8, it's either got to be 1 times 8 or it's got to be 2 times 4. That's it. Those are the only possibilities. Just think about the factors. I don't want to get into fractions and weird other stuff. No, we'll try and do this as whole numbers. Well, there they are. They have a sum of 9, so it's 1 and 8. So this is what is going to break down to. I'm going to make this 1x and 8x. 1x plus 8x. So I'm kind of doing this backwards. You know how we combine those in the middle? Now I'm going to break it down. 2x, I didn't touch that. 2x squared, leave it up front. Plus 4, leave it here. Now, watch what happens. See these two? They both have x. I can divide out an x. X, bracket, 2x plus 1. See these two? They're both divisible by 4. Positive 4 or negative? Let's take out positive 4. If I divide out positive 4, 8x divided by 4 is 2x. 4 divided by 4 is 1. Okay. Oh, recognize that? That factor is the exact same. That's a good sign. If this is the same factor, that means I can factor it out. So in other words, it's going to be a factor out front, 2x plus 1. And when I factor it out, I'm just left with whatever this is and whatever this is, x and plus 4. X plus 4. There we go. We factored it. So that's how you factor things algebraically. You want to look for two magic numbers. I call them the magic numbers. That's what the center breaks down into. It decomposes. So 9x, I could have made it 5 and 4, but that would have been useless. 1 and 8 will work because they have a sum of 9 and they have a product of 8. Okay, let's try this one. What do we got? 2x squared, 17x, and 16. Okay, so I'm looking for two numbers. So 2 times 6 with a product of 12 and a sum of the middle. Okay, so two numbers that multiply to 12. So it's either going to be 1 and 12, 2 and 6, or 3 and 4. Okay, so that's it. Those are the only whole numbers. I don't want to get into fractions. Those are the only whole numbers that are going to work in this case. Okay, so they have to have a sum of 17. In other words, they add up to 17. No, that adds up to 13. That adds up to 8, 7. This one's done. It is not factorable. In other words, it's done. There's nothing else you can do to this question. This is finished. You can't break it down into anything simpler. It's kind of like doing a fraction or something like that. Once you get down to, like, for example, 1/3, that's done. You can't break that down any further. Okay, hang on. Let's try one that will work. Um, 3x squared, 10x, 8. Now you can kind of see why it's kind of important. 3x squared, put the x squareds first, then the 10x's and the 8. Okay, so I'm looking for two numbers with a product of 3 times 8 is 24. And a sum of minus 10. Hang on, they add up to negative. Before they were positives, okay? But if they add up to a negative number, hang on, in this case, they have a product of 24. So they multiply to positive 24. They're either both positive or both negative. Psst, if they add up to a negative, they have to be both negative. Negative 1, negative 24. Negative 2, negative 12. Negative 3, negative 8. Negative 4, negative 6. That's how I... There it is. These have a sum of negative 10. And they have a product of positive 24. This is positive, which means they have to be the same sign. I knew they were both negative because they add up to a negative number. Now, if these are both positive, these are both positive. But if this is positive and negative, they could both be negative. It gets more complicated when this becomes a negative. But let's just factor this one down. Okay, so minus 4, minus 6, that's what this is going to break into. Now, there's more than one way of doing this. But my suggestion is, if you recognize a pattern, hey, see the 6 and the 3? I'm going to put those two side by side because they both have 3's. 3x squared minus 6x. And I'm going to put the 4 beside the 8 because they both have 4's. Minus 4x plus 8. Okay, let's do this. Factor out 3. Well, I can also factor out an x. Factor out 3x. X minus 2. These both have 4's. So let's divide out a 4. So I'm going to divide out positive 4. When I divide it out, I get negative x plus... Hang on, these are not the same. They're close. They're really close. I need these to be the identical binomial. That way I can factor it out. Oh, notice this. I factored out positive 4. What if I had factored out a negative 4? Let's try that. Okay, so let's go back here. So if I say minus 4x divided by minus 4, that's just x. 8 divided by minus 4 is minus 2. Now they are the same. Fantastic. That's what I need. So you'll know when you get it a little bit backwards. If you need to factor out a negative in order to make these the same. Now that these are the same, I can factor that out. So that's going to factor out. So that's going to be my first factor, x minus 2. And what's left over? I'm just left with this and this. 3x minus 4. There we go. That's factored. So this is considered factored form. So it's like something times something. If I was to expand this all out by FOIL, I would get back to here. But this is just basically FOIL in reverse. That's what I'm doing. Okay. Now let's switch it up a little bit more. 3x squared minus 10x and 8. 3x squared minus 10x and minus 8. It's almost exactly the same. But that little change from a positive to a negative is going to change everything. So let's see. What do I want? I want two numbers. They multiply to 3 times negative 8. Multiply to negative 24. And what do they add up to? They add up to minus 10. So they multiply to negative 24. That means one's positive, one's negative. So it's a 1 and 24. Hang on. They add up to a negative number, which means the bigger one's got to be negative. Okay. No, that doesn't work. What about 2 and 12? Remember, the bigger one's got to be negative. That's it, right there. 2 and minus 12, they multiply to negative 24. One's positive, one's negative. And I knew the bigger one was negative because they add up to a negative number. Okay, so there we go. So 2 and minus 12, that's what this is going to break into. So do you want to put the 2 by the 3? I'm going to put the 2 by the 8. I'll put the 3 by the 12 because they both have 3's. 3x squared, so I'll go minus 12x first, plus 2x, and then minus 8 on the end. Right? So plus 2 and minus 12, that's where these came from. So factor. These first two, I can always factor out an x, and I can factor out a 3. 3x, bracket. Divide it out, I'm left with x minus 4. These two, they both have 2 in common. Positive 2. Hang on, should I take out positive 2 or negative 2? Well, let's take out positive 2. I'm left with x, 8 minus 4. Yes, it's the same. Good. Leave that as positive 2. Now, if this was backwards, like negative x plus, then I would factor out the negative. But there it is. That can factor out. The binomial itself can factor out. X minus 4 is one of the factors. And when I factor it out, I'm left with this and this. 3x plus 2. Notice, completely different answers. Switching that minus or the plus to a minus made a whole different question out of it. Okay, so let's finish up here. When we were doing the algebra tiles, right? These two middle numbers, they were simply the x's on the side and bottom. Right, now there's more than one way of drawing these things, but we said, look, if we know we're going to do an x squared, let's do the big x squared in the corner. We'll use up the biggest area first, right? There's my big x squared. And then we said there were 7 x's. Well, I don't know how many, all these x's, they either have to go here or here. Here's the clue. You want to look at the 12. So 12 is either 1 times 12, or it's 2 times 6, or it's 3 times 4. If it's 3 by 4, then this is 1, 2, 3, 4, and 1, 2, 3. That makes sense. That's where the 7x's come from, right? So, hang on, see if I can draw these. 1, 2, 3, 4, and then, okay, these are really, really thin. But you can see that there's 7 x's, x, 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 x. Now the 3 by 4, I got my clue from the 12 because I know that I'm going to put those little ones in the corner. So there's 12 down here. So this becomes x, 1, 2, 3, 4, plus 4. This becomes x, 1, 2, 3, plus 3. So those are the factors. X plus 4, x plus 3. So this is the binomial. This is what it is all expanded out, but this is what it is in factored form. Yeah, so those 4 x's and the 3 x's, they were here and here. Here's my clue. I know it can't be 5 and 2 because those don't multiply to 12. So, right, think about it. What two numbers add up to 7, but they multiply to 12? That's why it's important to have these in order. Okay, let's try this. Try this last one. 6x squared minus 10x and minus 4. Okay, I'm not going to be drawing 6 big x squareds, but you know what? Notice they all have 2 in common. Step 1, factor out the 2. Oh yeah. If you can divide out 2, let's do it. 2 bracket. Divide it out from all of these, I'm going to get 3x squared minus 5x minus 2. Okay, that's an easier question to do because the numbers are smaller. So I'm going to do that, and then I'm going to put the 2 back in at the end. Okay, so what am I looking for? I'm looking for two numbers, 3 and minus 2. They multiply to give me negative 6, and they add up to give me the middle, minus 5. Okay, so they multiply, it's either 1 and 6 or 2 and 3. But are they both positive or both negative or what? Hang on. Multiplies to -6, which means one's positive, one's negative. Psst, the bigger one's negative because they add up to, so it's either this or this. These add up to -1, no good. These add up to, there it is, these add up to -5 and they multiply to -6, there we go. So that's what I'm going to decompose the center into, 1x and -6x's. So here's the question. Where do I put the 1x? Where do I put the 6x? I'll put the 6 beside the 3. So 3x squared minus 6x. Okay, and then plus 1x minus 2. There we go. So you see the center decomposed into 2. I know I've got a 2 out front. I'll make sure that comes back in the end. These two I can factor something. I can factor out a 3. I can factor out an x. So divide it out. I'm left with x minus 2. These two, what can I factor out? Nothing, but I have to factor out something. So you know what? I'm just going to factor out positive 1. So in other words, I'm just dividing out positive 1. It's really 1 x. Negative 2 divided by 1 is -2. Notice it's the same. That's the important thing. So that's why I have to factor out something. I need something to be here. So x minus 2, whew, that's going to be a, that can be x minus 2. That's a factor out front. When I factor it out, I'm left with the 3x and the plus 1. 3x plus 1. Oh, and don't forget, we had a 2 out in front. So this thing's actually 3 factors, if you will. Well, this is just a number, but there's 3 factors. 2 of them are binomials. If I was to expand this all out, I would get back up to the original question we started with. Alrighty.